ending. And that, my friends, is the secret to software architecture. Thank you. You're welcome. You're welcome. Now, just keep that in mind, and you will never have a failed project again. Anyway, back to the topic at hand. So 4.5 stars for this fine dining establishment. And there's another one that was next on the list that had a 4.2 rating. So you would expect, right? Comparable experience. Do you have any reason to doubt that? I sure don't. What was that 4.2 star option? There it is, McDonald's. There's a problem here. 5-star ratings are not created equally. We don't have a standardized scale. In fact, the only standardized scale we have is, as Randall Monroe of XKCD fame has told us, that 5 means it only has one review. 4.5 means excellent. 4 means okay, and everything else is garbage. Now, my wife has a hobby. Years ago, when I proposed to my wife, being the magician that I am, I had a little bit of misdirection. I was, some smoke and mirrors because she knew there was an incipient proposal, but she didn't know when, she didn't know how, and she didn't know where. She also knew that we had reservations to a restaurant about an hour or so outside of Rome in Italy. In a little hamlet called Vaccone. And the name of this restaurant is Solo per Due, only for two. And Solo per Due is exactly what the name would suggest. It's a restaurant that has one table, a two-top, and they do 2 seatings a day, lunch and dinner. And we bought the dinner. It was our restaurant for the night. They made the menu for me and what I had told them. The gentleman, Signor Di Claudio, he said, "What kind of flowers does your wife like?" I said, "My wife likes orchids." He filled this restaurant with orchids. I think he spent our entire meal budget on orchids. It was a beautiful experience. It was incredible. This old man, he just loves love. And this is his passion. And everything about that experience was transcendent. And in fact, the restaurant operator also runs a little kind of Airbnb type of thing, a little stone cottage in the middle of an olive orchard. It's a beautiful place. And we could stay the night there. Instead of having to go back to Rome, we stayed the night. 99 euros. It was very affordable. And we're back in that little cottage. And she's on her phone. I said, "What are you doing?" She says, "I'm reading all the 1-star reviews for this restaurant." That's her hobby. When she finds this magical place, she'll read the 1-star reviews. It's like, okay, what was it that somebody who could only find the negative in anything did they hate? Because there are people who just find something to hate about everything they ever do. And they were just petty things like, "They didn't have any organic wine. Can you believe it?" Or, for that price, I could go eat a Michelin-starred place in Rome. And yeah, you can wait and get reservations and do all the other stuff, and it would not be the same. And so that became her hobby. And everywhere we went that we found somewhere amazing, she'd go look up the 1-star reviews. Now, we found ourselves a couple of years ago in Tokyo. In Tokyo, we found this amazing little corner, little sushi place. You walk up to the counter, and the sushi chef looks at you. He says, "Hi." And you tell him what you want. And if you're not ready, he'll hand you the bill. Because it's like, if you're not ready, you get in, you eat, you get out. And then he would just it was like a craps table. There were two sushi chefs. They each took half of that little counter. And he would go to you. He's like, "Hi." He'd be like, "Otoro." He says, "Hi." He goes and makes the otoro and gives it to us. And then he turns to the next person, takes their order. And by the time he gets back to us, we better be ready for that next order. And he says, "Hi." I said, "Otoro." And he says, "We have other fish, but otoro is the secret." That's the other secret. And then afterwards, this place was so incredible. I wasn't Jiro dreams of sushi, but like you could see it from there. And the average review was 3.2. And she was so baffled. And the reviews, even the low reviews, were fine. Because Japan, they do things differently. Japan, they have a standardized scale. Somebody said, have you noticed a difference in how Japanese people rate things on Google, Amazon, restaurants, etc.? And somebody said it's a culture of rating here. A 3 means something was just as expected. For us, 5 means just as expected. That's why McDonald's has a 4.2. It would be a 5, but sometimes your fries are cold. 4 means it exceeded your expectations, and 5 is extremely good. It's quite rare to see a 5. 2 is a little below expectations. It's not harsh. It's just normalized around 3. And somebody even said that, like they said they saw a review. It says, I had a fantastic meal and the price was really cheap. I'm happy to have found this place while out for a walk. However, there was a plastic bottle rolling around the car park. I wonder if the boss knows. 2 stars. So let's quantify this a little bit. Let's dig a little bit deeper. Because one of the more famous exemplars of microservices is, of course, Amazon. Amazon's good at this kind of stuff. Let's just look at a couple of these. Let's look at our agility and deployability. What is 5-star agility, 5-star deployability mean? Well, at Amazon, that means 136,000 deployments a day. Now, what about scale and elasticity? Well, at Amazon, at its peak on Prime Day, they're serving up around 50 million HTTP requests a second. Now, let's contrast this with a monolith. Monoliths, if you look at them, they have a lot of 1 stars and very few redeeming qualities. We know monoliths are bad, microservices are good. But in the e-commerce space, there is Shopify. Shopify very famously has a modular monolith, which is a slight twist on the classic monolith pattern that you might know. But in terms of agility, it's only 2 stars. In terms of deployability, it's only 2 stars. What does that mean? It means they're doing 40 deployments a day. Anybody doing 1 deployment a day? Yeah, we need that 5 stars when we're doing like a deployment every 2 weeks. They're doing 40 deployments a day. What about scale? Well, they're not as big as Amazon, but they still kind of average out around 1.27 million requests a second. And that's 1 star. And it really makes you think about scalability, because there's this notion that you're only going to be scalable if you have microservices. They have a Rails monolith. How many times in your career have you heard the notion that Rails doesn't scale? This is a big old Rails monolith, like backed by MySQL or something like that. And they have hundreds of developers adding features, 40 deployments a day. So that was why when I wrote this book, I said there's some good stuff in the work that Mark and Neil did in their book, but I'm going to change this scale a little bit. So we look at microservices now. I've actually come up with a way to calculate this rather than kind of my best guess on my architectural instincts. There's actually a way to quantify this and calculate this based on the definition of this architecture, or a definition of this architecture, because it's a family of architectures. But what we're up here in our agility, it's extremely high. Deployability is extremely high. Elasticity, extremely high. Now, extreme has a very different connotation than 5 stars. It becomes a very different discussion. Now, I mentioned that quote from Martin Fowler. I'm going to quote him again. Well, the Martin Fowler's blog, I'm not sure who wrote what. I think actually James Lewis wrote one or the other of these posts, if not both of them. And he said this: as I hear stories about teams using microservices architecture, I've noticed a common pattern. 1, almost all successful microservice stories have started with a monolith that got too big and was broken up. 2, almost all the cases where I've heard of a system that was built as a microservices system from scratch has ended up in serious trouble. The pattern has led many of my colleagues to argue that you shouldn't start a new project with microservices, even if you're sure your application will be big enough to make it worthwhile. And in fact, Gartner, unironically embodying the Gartner hype cycle, Gartner said this. By the end of 2019, this is when they were in the trough of disillusionment part of the Gartner hype cycle, because about 6 months earlier, they were predicting that everything was going to be microservices from here on out. And by 2017, they said by the end of 2019, 90% of organizations that try to adopt microservices will fail. They will find the paradigm too disruptive. And it's not that just because they can't do it, they're not technically capable. There's a lot more going on in here. So I have a new philosophy. Some time ago, I was driving through the desolate wasteland that is a state that I share a birthday with, Wyoming. Wyoming became a state on July 10th, 1890. Also, I'll share a birthday with Nikola Tesla. July 10th is a good day. Now you said Friday, Saturday. Saturday is not bad, but I got Nikola Tesla. I'm just saying. But I'm in Wyoming. I'm actually from Wyoming, and I don't remember what I was doing there, but I was in the middle of the state on this desolate highway. I've been on this highway going highway speeds for 90 minutes at this point. Haven't seen a soul, not a single car, not even a groundhog or an antelope, just driving in some pretty barren flatland parts of Wyoming, not the beautiful part that they put on postcards, like the rest of it. And out of nowhere, not on my GPS, I start driving through a town, a modern town, a well-equipped town. I drive past a very enviable-looking high school that was much better than the high school that I went to in Green River, Wyoming. And as I'm driving through, something's kind of off. Not in an obvious way, but in the kind of eerie way that eerie vibe that you get in the first act of a horror film before you really know what's going on. And finally, it dawns on me there is not a single person here. It's a ghost town. It's a ghost town in the middle of Wyoming that is completely abandoned. It was built in the 1970s, and by the mid to late 1980s, everybody had left. It was a company town for a uranium mine. You know, some things happened in the uranium market in the 80s. I don't know if you remember. I know 97. So I'm not, my first 80s reference to you, sir, was wasted, but so you probably may or may not know about some of the things that happened in the 80s. A couple of big things happened. First, there was the whole Chernobyl incident. There's also the 3 Mile Island incident, which they are booting back up. Hooray, to power the AI data centers. And then, of course, the Cold War kind of came to an end in the 80s, and maybe we didn't need 2,000 times the number of nukes to completely destroy the planet and growing. So we stopped building, stockpiling weapons of mass destruction. And as a result, it was just not a good time to be in the uranium market. So the mine was no longer profitable. They closed it down. Everybody just left because what else are you going to do? And as I'm driving through, I see this place right here, Monk King Bird Pottery. There were signs, big flags on lining the highway. We are open. Come on in. It was the only sign of life I saw. Curiosity got the better of me. I, turned around, went in there. I got to see what this is. And I met this man right here, Byron Seeley, the Mad Potter. I don't know if he was always mad or just living by himself in a ghost town in the middle of nowhere in Wyoming. Kind of drove him mad. Or the amount of alcohol he consumes. When I met him, he had a big red Solo cup that was filled to the brim with vodka. It's 10 a.m., by the way. He was steaming drunk. But he's a nice guy, and he shows me around his live-in studio retail space. He bought that building, what used to be a mechanic shop and gas station for the town. He bought that shop and then 500 acres for $5,000 for all of it. And I'm talking to him. I'm curious. So I said, Byron, this is an odd choice of retail location you got there. I said, tell me, do you get a lot of business? And he just looks at me. He says, what's a lot? I was not prepared for the follow-up question. So I said, I don't know. He says, neither do I. I know what enough is. I get enough. I said, okay. Yeah, so this is some wisdom from the Mad Potter. That we don't want a lot. We want enough. And we hedge with a lot because we think that we can't grow with our architecture. And that is a fundamental misunderstanding of software architecture. That's one of the reasons I wrote this book, because architecture can be evolutionary. It should be evolutionary. And changing architectures is not necessarily hard. I'll talk about some of this stuff in a little bit. But here's the thing. So I'm kind of talking negative about microservices, but these things still matter. But the question that I want you to consider, are microservices the only way to achieve these things? And if nothing else, the Shopify case study says, no, not necessarily. So our first secret, nobody really wants microservices. What they really want is something they think microservices are going to give them. So every time I do a consulting engagement where they want to modernize their architecture, they say, we want to move to microservices. I said, are you sure? Why? I said, that's great, but what do you really want? Why do you want to do this? Second law of software architecture is why is more important than how. Now, the other thing that I talked a little bit about, the second secret, and this is a challenge, is there's no single definition of microservices. So you have a large organization, and you're the architect, and you go out and say, okay, we're doing microservices. This is a problem because all the people on those teams who have microservices on their resume, they definitely worked on something that somebody said was microservices, but they're not the same thing. And microservices requires the entire team to be working with extreme precision in a very unified way. I had a conversation with, I'm actually surprised my contract is still going on because at one point I was on an all hands meeting and the vice president of whatever, vice VP level dude who's in charge of all the IT, he said, we have a directive. I'm issuing a directive from on high that we are going to start doing everything as microservices. And they made the mistake of letting me unmute myself. So off mute, I said, that is an astonishingly terrible idea. And I got a message from the person that I reported directly to who reports to that guy. He says, why don't we talk about this offline? And he says, what do you mean? I said, look, that's not going to give you what you think it's going to give you. I said, this is like buying a Formula One car because I want to be a race car driver. But the reality is you got to be a race car driver before you can drive a Formula One car. But the other thing that's really important is that even if you have the best driver in the world behind the wheel of that Formula One car, and it's the best Formula One car ever conceived, you're still going to get nothing but an unbroken string of spectacular losses if the entire crew is not working with laser precision. I actually just saw the new F1 movie, and it kind of bums me out a little bit because it takes a little bit of the wind out of my sails. But if you haven't seen it, do you know how long a Formula One pit stop should take? That's where you want to be, 2 seconds. Change the tires, fill up the gas, on the road again in 2 seconds. Like, that is very difficult to achieve. And you need everybody heavily rehearsed, in unison, lockstep, reading each other's minds, doing every one of those choreographed moves millions of times to get that kind of precision. And that's what it takes. That's what it takes. And if you don't have everybody super unified in that process, a lot of things are going to go wrong. Now, one of the problems we have here is what I like to refer to as the flat taxonomy. We have monoliths and we have distributed, but generally everything in the distributed category kind of gets lumped under microservices at this point because there are so many competing definitions that we just sort of revert to the lowest common denominator. Somebody told me that doesn't mean what I think it means. I said, I know, but that means what they think it means. He says, really, it should be the greatest common factor. Whatever, dude. Yes, you're right. You're technically right, which is the best kind of right, but no. And we've just basically kind of decided that everything here is bad and everything over here kind of sort of is good. Everything here is kind of sort of microservices. But when we revert to this lowest common denominator or greatest common factor, Jerome, I see you. You're associating all of these capabilities with the topology, not the numerous architecturally significant decisions and the process and the culture changes and the organizational changes and all these other things. So what ends up happening is we've all worked on bad monoliths. We've all been there. I've built a bunch of them. And you know what's horrifying is they're still around. That's karma that I have to carry for eternity. But this is not the same as this. This is not the same as this. And but when we look at the topology, we're like, well, if we just break things into a bunch of little tiny pieces, magically all those capabilities will appear. And in fact, I'm going to quote Martin Fowler again, or his blog at least. He even says this. He says, there is no precise definition of this architectural style. There are certain common characteristics around organization, around business capability, automated deployment, intelligence in the endpoint, and decentralized control of languages and data. That's the problem. So how do you hire people that have experience with your particular flavor of microservices? And because ultimately all those 5-star ratings, they don't just magically appear when you break things into hundreds of tiny pieces. And in the same way, a layered monolith or a modular monolith does not presage a big ball of mud, even though they have the same deployment footprint. They're all a product of decisions, and there's no correct set of decisions. Now, what I found generally, as I've tried to become a better architect over the last 10, 15 years, is there are two types of books out there. There are the ones that just tell you how to think about designing a system. They're not very popular. My book, not very popular. And that's the problem, is like, don't just tell me what to think. I'm busy and there's a lot of information that I have to consume. Just tell me what to think. And that's just something I'm not going to do. I'm going to teach you how to think. And I'm going to teach you how to think about designing systems and things like that. And the other ones that are much more popular, they're the people who have gone into some organization, some domain, and through years and years of trial and error, they have cracked the code for them. But they think they're special. They say, I figured it out. If you do exactly what we did in our domain, in our organization, which is nothing like your domain or your organization, you will be successful. And then about 3 or 4 years later, they call me. So you get a lot of these. The point is there's no single correct set of decisions that apply universally. And the problem as well is, even if the architect does their due diligence, right? They read Sam Newman's book. They read Mark Richards. They read Michael Carducci. They read, Chris, the Microservices patterns guy. His name's Chris, right? Chris Robertson, something like that. Yeah. I don't know. If you post this online, within 30 seconds, there'll be 100 YouTube comments. They're like, you moron, it's so-and-so. So I'm going to leave it to them. Maybe you've done your due diligence and you've really studied this and you really understand it. Except the architects aren't the one actually building the system. This idea of patterns, right? Patterns are supposed to be a high bandwidth mechanism to communicate shared ideas. But that only works if when I say, oh, we're going to use the observer pattern, you're like, cool, I got it. Or we're going to use the strategy pattern. You're like, got it, right? Microservices, not so much, because it's not nearly so well defined. So it's not a very efficient mechanism for communicating these things. That means that at any meaningful scale, there are no shared definitions of any architecture pattern. And I mentioned this already, the problem of the flat taxonomy, that, right, these have the same topology, that therefore they must be equally bad or equally good if you're feeling glass half full. But the thing is, there is an ocean of difference between the big ball of mud and the modular monolith and the layered architecture in the middle. Now, Big Ball of Mud was popularized by a paper by Joseph Yoder and Brian Footy. I'm not sure if that E is like accented or not. Usually I like our simplified alphabet, but sometimes I wish we had the accents because like I could figure it out. I worked with a bunch of, before all the unpleasantness started happening, I worked with a bunch of Russians, and they would try to transliterate their names. And I'm like, dude, can you please just show it to me in Cyrillic so I know how to pronounce it? Because I was learning Russian because I wanted to start breaking down this whole us and them thing, and I could finally read Cyrillic. And, but yeah, Joe Yoder, Brian Footy. I've not heard it either way, so I'm just guessing. I'll be wrong at least half the time. But they wrote a paper in 1997 about the big ball of mud. And in the beginning, in the abstract, they describe this architecture. A big ball of mud is a haphazardly structured, sprawling, sloppy, duct tape and baling wire spaghetti code jungle. We've all seen them. Their code shows unmistakable signs of unregulated growth and repeated expedient repair. Information is shared promiscuously among distant elements of the system, often to the point that nearly all important information becomes either global or duplicated. The overall structure of the system may never have been well defined. If it was, it may have eroded beyond definition or recognition. And as a result, programmers with any shred of architectural sensitivity will shun such things. Only those who are unconcerned about architecture and are comfortable with the inertia of the day-to-day chore of patching holes in that failing dike are content to work on such systems. But haphazardly structured, spaghetti code jungle, information shared promiscuously, right? That's not what we're seeing in these other patterns. These are actually pretty well structured. And they're structured for different goals, but they're fairly well structured. This is why we can't define architecture by its lowest common denominator. Mark Richards, I like his definition. It's a good place to start. If you had to describe microservices in a single sentence, Mark Richards will say, a microservice is a single purpose, independently deployable unit of code that does one thing well. Now that's a good definition, but it can lead us in the wrong direction. We want to do the pattern right, but only if the pattern is right. We want to avoid pattern-driven architecture because patterns aren't architecture. They're not. They've become a proxy for architecture. Kind of like organizations that kind of pay lip service and try to check the checkboxes around Agile. They go into all their documents and they do a find and replace. They replace project manager with Scrum Master. And suddenly we can check and we have stand-up meetings now. We have 2-hour meetings where we're all kind of leaning. It's like, yeah, we're Agile now. No, you're just trying to check the box. But patterns aren't architecture. They are a side effect of architecture. And that's why I feel like we are long overdue for a more comprehensive architectural model. So I'm getting old now. I'm even older today than I was yesterday. My wife actually, this is the first thing that she said to me this morning. She said, "Good morning, old man." I hadn't had my coffee yet. I was unrestrained. The locks might be changed by the time I get home tomorrow. Because my response was, you know, it's funny. I keep getting older. But you're still even older. That one's going to come back and haunt me. But since I'm getting old and I can't keep up with the latest trends, I used to be with it. And then they changed what it was. Here's an outdated meme. Decision-driven architecture. Because here's the thing. Within any project, there exists a set of decisions. Now, within that set, there exists a subset that directly impact the capabilities of the system, the ilities, the architectural character, whatever you want to call them, that directly impact the ilities, if you will, the architectural ilities, the system quality attributes, non-functional requirements, capabilities is what I call them these days, directly impact the capabilities and their measure. You give me a set of requirements, functional requirements. I can use any of these patterns to deliver those requirements. In fact, I've come to the conclusion that there's a near infinite number of ways to write code to deliver a set of features and functions. Now, as diverse as these patterns are in terms of implementation and topology and capabilities, each of these is just the result of a handful of architecturally significant decisions. Decisions around component granularity, topology, how module boundaries are defined, if we have any kind of data persistence isolation, how module interfaces are constrained, constraints around code reuse, if and how asynchronous communication is going to take place. So all of these patterns are really just different combinations of a relatively small number of architectural constraints. This is a weird way to think about architecture, but I think it's a fantastic way to think about architecture. Capabilities don't come from the patterns. They come from, they come from the ways that you constrain the degrees of freedom. Your big ball of mud is defined by no constraints. It's a free-for-all. Make everything global. Where's your God now? You want a 30,000 line God class? Speaking of God, you want a 30,000 line God class? Have 5. There's no rules. It's post-pandemic. I can go grocery shopping in my pajamas. Nobody's going to stop me. Now, this idea of architectural constraints is not a new idea. In fact, I learned about this way back when I read this particular paper, Architectural Styles and Design of Network-Based Software Architectures. Now, has anybody read this paper? This is Roy Thomas Fielding's 2000 doctoral dissertation at the University of California, Irvine. This is REST. Have you read it? Some of it, yeah. Most people skip directly to chapter 5. Because chapter 5 is, and that's what I did too. I'm not throwing shade. I did the exact same thing. And then I got really mad because it didn't tell me anything about how to design my APIs. But chapter 5 is where Roy Fielding first introduces REST. I read it. Didn't make any sense. I read it again. And then I decided all of this is stupid. And then I went and did my own thing for a while. And eventually I went and read the whole thing cover to cover. It's actually worth reading. It's a very, as doctoral dissertations go, it's very accessible. And I read the whole thing, and I realized, oh, it's not about REST. Now, the title, Architectural Styles and Design of Network-Based Software Architectures, should have been a clue to me. But I'm not the sharpest bulb in the shed, or however that saying goes. It was actually about architectural design by constraint. Now, he cites Perry and Wolf, 1992, Foundations for the Study of Software Architecture, where they did a lot of work on this. And when we look at this, there's actually kind of an interesting timeline. You can go back to 1975 to read some Fred Brooks. This is classic stuff. To the kids in the room, and I'm looking at you, 97. Not everything from the 1900s is obsolete. Now, there are things from the 1900s that are obsolete. Don't get me wrong. But not everything is. There's some ideas that are timeless, and we ignore these to our peril. Like I see teams every single week who have to relearn the fallacies of distributed computing. Because why would I go read that? That's from the 70s. But 1975, Fred Brooks talks about this. Why did the Tower of Babel fall? There were no constraints. 92, Perry and Wolf. 96, Shaw and somebody else. Software Architecture, Perspectives on Emerging Disciplines. 2000, Roy Fielding's dissertation. The Software Architecture Constraint Reuse by Composition, 2016, by Tibber Messine et al. I'm not even sure I'm pronouncing that correctly, and that's why I'm just defaulting to the et al. And then the Tailor-Made Software Architecture Model, which is detailed in the book, is in there. We're giving it away, by the way. But the thing is, the idea is not new. And this idea of connecting constraints to your architectural capabilities has been shown to work again and again in theory and in practice. Now, what's really exciting, when I read that paper, Fielding's paper, and I finally understood it, he said something interesting. He said that architectures are defined through composition of architectural constraints. And these behave so deterministically that in theory, it's possible to weight these constraints on how we add this constraint to our architecture. It's going to take one capability, kind of move it up a little bit, and another one is going to move it down. It's the trade-offs inherent to software architecture. You said, but that would require somebody coming up with a set of common definitions of these patterns and then assigning some kind of quantitative scoring system. And then in 2020, Mark Richards and Neil Ford did exactly that. And they were regulars on the No Fluff Just Stuff tour, and I watched this evolve from thumbs up, thumbs down, thumbs sideways, eventually evolving into this architectural scorecard. And through that, we were able to, I was actually able to, based on their definitions of the patterns, which are a little too prescriptive, in my opinion, but still very useful, actually calculate those weightings. Get design time feedback on your decisions before, instead of building everything and then deploying it and finding out you're entirely wrong. And there's even more that goes with that. But when you have a set of architectural constraints that you are prescribing for some subset of your system. That's not a pattern anymore. That's an architectural style. An architectural style is a name-coordinated set of architectural constraints. So we can go and define these patterns. Yeah, that's Roy Fielding. We can define these patterns by their core constraints. And what we're really doing is we're kind of defining the core of these patterns, because nobody just uses those constraints. Like if you have a layered monolith that has an API, that's an architecturally significant decision, and different API choices have different sets of trade-offs. So look at microservices. Well, we're looking at this fine component granularity. Another constraint, independent deployability. Take that away, you don't have microservices anymore. You have a distributed monolith. And you get the worst of both worlds if you've ever been there. I spent a lot of time there. It's not fun. Domain partitioning, that's a big one. Most people, because when we're carving up these new module boundaries, we need to find new seams in the systems. And the only reliable and repeatable way to do that is through domain-driven design. And most organizations won't do that, or do the bare minimum, and then they have to rediscover Conway's law, that it doesn't matter what you design, you're going to get essentially a copy of the org chart in the final system. Highly decoupled components. That means making major trade-offs like duplicating code, isolated databases. There's some kind of API in there. And when you violate different ones of these, you don't have microservices anymore, and bad things start to happen. But we can selectively adopt only the constraints that will elicit enough of a capability. And if the next architecture in our evolution is that becomes just adding or changing a constraint. Now, some constraints are harder to change than others. But down to our second secret, there's no single definition of microservices, but that model gives us a common foundation to avoid overlooking key foundations. Now, the third one is the trade-offs of microservices, typically more than we might expect. Remember this. This is not because 90% of the organizations got the constraints wrong. There are a lot of other things there. And in fact, about a couple of years ago, there was a very famous high-profile case of I think it was the Amazon Prime Video team. They decided, you know what? We're going to put everything back into a monolith. That actually makes a lot more sense. And there was a big... Boy, Zoom just kind of steps on my animations, doesn't it? Is what it is. Welcome to the post-COVID era. I still love you, remote viewers, both of you. Is it still 2, or did one drop off? 6. Oh, I love all 6 of you. I love y'all even more now. But the thing is, despite their capabilities, they don't always fit. Let's talk about the history of microservices for a moment. Every now and again, I have this fantasy. Now, unlike why my solstice was quite memorable this year, I can talk about this fantasy. This wasn't a fantasy. I'm just going to stop talking. Somebody take over for me. I like it here. I would like to come back. So I'm just going to move right along. We're going to pretend that didn't happen. There is no list. I was hoping I would get at least a chuckle, and now I'm uncomfortable. Thank you. I'm sure somebody on Zoom chuckled, but they're muted, and that's very polite of them. My fantasy involves this. Waking up one morning, and it's not today, it's years ago. Like 95, 98, I don't know. And going back in time, but knowing everything I know now. Like, what stocks would I buy? What technologies would I invent? Right? That was one of the big gags in Hot Tub Time Machine was Lou. Was it Lou or Stu? I can't remember. Lou? He's like, yeah, you go back in time, you can invent Google. And they called it Loogle or something like that. And it's like, yeah, just invent a search engine, because there's a little more to it than that, but you get the idea. That I'd go back and I'd invent Google. I'd invent PageRank. I'd go buy Apple stock, back when it's trading for split adjusted like 2 cents a share. And but imagine I went to an event like this and I laid out my vision for a brand new way to think about software architecture. What a visionary they would see me as, right? I'd get a Turing Award, surely. Except what would really happen is they would probably ask me politely but firmly to leave. Because what I was describing wasn't just revolutionary, it was impossible. Like, it was impossible. We couldn't do that before. It only became possible through the influences of changing cultures, advancements in technology, evolving practices, organizational theories that became practical. So there are X factors in all of this, and there are a bunch of them. These X factors are the hidden variables that make microservices successful. The pattern itself, the defining constraints, can't operate effectively without the X factors. And those drove the development and the success of this approach. What are they? Well, one of the first ones is the influence of the Agile Manifesto. That was a recognition that change was inevitable, that we don't build software, we change it. And so why don't we think about optimizing for change rather than optimizing for building it? We need to embrace new methods to facilitate change. We had emerging practices that started to influence in this. These are things like test-driven development. It was created in 97 by Kent Beck, tools for fast feedback and correctness. Continuous integration, continuous delivery, the rise of DevOps. Those started to enable operational automation. Now, such a modular architecture required precise module boundaries. So we needed to know what to do about Conway's Law. And we didn't get that until 2003 when Eric Evans wrote Domain-Driven Design. I met Eric Evans last year, I think. Had dinner with him. He's a very nice guy. And I had to confess to him that his book occupies a very special shelf in my home. It is my shelf of shame. It's sitting next to Infinite Jest and a few other books that I have never finished. And everybody at the table laughed. Joe Yoder was there. A bunch of people. Alberto Brandolini, the event sourcing guy, he was there. Bunch of like big DevOps guys were there. And they all started laughing. They said, "Oh, you read it wrong." I said, "I did." They said, "Yeah, you probably read it front to back, didn't you?" I said, "I tried to." They said, "No. You do. You're supposed to read it in this order: Section 1, Section 2, Section 5, Section 4, Section 3. I was like, "Oh, of course. Why didn't I think of that?" But these are some of the key X factors. These are additional constraints, but they're constraints of a different kind. So in other words, we have microservices described as highly decoupled, independently deployable, fine-grained components that each control their own independent database, grouped by domain, partitioned by the bounded context, communication facilitated by some kind of API, interface running on an environment with high operational automation. Great, let's take this apart. It means we need an investment into DDD. We need domain-aligned teams because you need to do the inverse Conway maneuver after you do your DDD. In other words, you redo the org. You need sophisticated development teams. That means they are sophisticated enough to know what the rules are and know when and why to break them. We need very mature development processes. We need high automation in dev. We need no shared dev environment. Our shared dev environments, this is like what you're doing, you need to take your shared dev environment and nuke the site from orbit. It's the only way to be sure. Did that one land? Or is that too niche of a reference still? Because that's also before your time. Nuke the site from orbit. It's the only way to be sure. Okay, all right. Oh, I got a thumbs up there. Sorry, I don't mean to be picking on you, but I'm feeling very old right now, and I'm trying to feel good about it. And so you're like my I'm getting old whipping boy. So that's on me. That's not on you. But what else do we have? Yeah, like this stuff here, this DevOps stuff. This doesn't just mean you take your existing ops team and rename them DevOps so you can be buzzword compliant. It means the whole organization has to change how they operate. And the upfront investment in testing and automation feels like impediments. And without strong team and organizational commitment to these values, the practices are going to be short-lived. You need team independence. That means you got to do things like API-first development. Otherwise, one team is blocking another team, and that's just not going to work out. You need these CI/CD pipelines. I have a note here. It says, if you have a long-term DevOps team, don't kid yourself, ... That's what it says on my notes. You need that environment that enables high operational automation. Yeah, probably the cloud, but the cloud just supports this. It doesn't just using the cloud doesn't automatically make this so. So you have to, this is a very difficult architecture to fit the team, the environment, and the organization. And it's like, it's one of those where, I can't remember what movie I watched, but somebody was getting married and she had a Vera Wang dress, and she was worried about fitting into it. And somebody said, well, why don't you just have the dress altered? said, no, you don't change Vera to fit you. You change you to fit Vera. And that's kind of what it's like with microservices. So this is why the tailor-made metaphor and all this other stuff. It's all about fit. Does your architecture fit? Does it fit the teams? Does it fit the organization? Does it fit the business goals? Does it fit the business climate? Is it going to fit the business future? Just like a suit doesn't just have to fit your body. It has to, like, it doesn't matter what your body shape is. If you have a suit that fits, you're going to look good as a man. Women's clothing, I know nothing about women's clothing. It is mysterious and baffling to me. I tried one and only one time to shop for my wife. Never again. That is a minefield. And so what I'm saying is I'm already on thin ice. And then I said what I said this morning. But just like in the same way, a suit doesn't have to just fit your body. It has to fit your wardrobe, the environment, and all this stuff. Your architecture has to fit across all of these different dimensions. And that requires extensive tailoring. So if you just dive into microservices without thinking about fit, it's probably going to fit about as good as that suit. So these are constraints too, but these aren't constraints on the system. They're constraints on you, the architect. These are non-architectural constraints. I break them down as team constraints, organizational constraints, and environment constraints. And that's the second thing that I did in this model was to take these architectural constraints and find their dependent constraints. And this means that some of these are quite demanding. And that means that either you have to change the entire organization or you have to change the architectural decisions that you're making. But so the trade-offs are often more than we expect, but we have a model that connects the capabilities to the constraints and things like that so you can be better prepared for architectural risk. Now, the fourth one, I ask this question from time to time. I'm going to ask this question now. Is anybody here in the midst of a monolith to microservices migration? Anybody in the room? One? Okay. One, two. The prior company. When you left, were they still in the middle of it? How many years into it were they? Okay, that's about right. Yeah, no, the average, the mean, and the mode, by the way, for the stats nerds in the house. The mean and the mode was 5 years. And in the middle at year 5. They're still working on it. Typically, it takes 5 to 7 years is what I found. And so we have this idea that, and that's one of the reasons people try to build microservices to start, because they did this for a while and they're like, this really sucks. Why don't we just start where we want to end up? And because decomposing a monolith is super, super hard. It's not necessarily. So what I found over the last 7 years of doing R&D with clients and reading and research and all of this stuff that I've been doing is it's not necessarily hard. Like, I have a system right now that someday might be microservices. And you know what it's going to take to decompose that system? One sprint. One sprint. It's not necessarily hard. Because what I discovered is that with this model thinking in terms of constraints rather than these vague, discrete topologies, is that all we're really doing is we're adding or changing constraints. Now, we can easily decompose a layered system into a distributed system, but let's actually just look at this in action, right? So we have our big ball of mud, right? Here we are. This is our big ball of mud. This is an architectural style. It's we call it a big ball of mud style. It's defined by one constraint: monolithic deployment granularity. I suppose if you take this away, I don't know what it would be. A puddle of mud, maybe? I've seen those systems. They're just piles and piles of ad hoc scripts, many of them running for the last 10 years in some long departed employee's screen session. Yeah. Who? Yeah, you've seen that, haven't you? That's fun. I did that once. I was looking at the servers. I was like, why is this person still logged in? I could kill their session. Whoops. people started screaming. And I had no idea what it was. No idea. It took us a week to get that back. But right, nothing really good about it. It's pretty simple to build, maybe not very simple to maintain. That's why it kind of scores in the middle there. You get okay performance, not great, because none of the code's particularly optimized, but we're not making network hops. So let's add like a separation of concerns. Right, we do that, things start to change. It's going to improve our total cost of ownership and testability. Let's add a shared database. There it is. It's going to improve our cost or simplicity or performance. We can add more modularity by applying some more boundaries, by defining boundaries by technical concerns. This is the UI. This is the business logic. This is the persistence. This is whatever, right? However you want to define those layers. And when we do that, we get an architectural style. Let's keep going. So what we have is a direct result of the architecturally significant decisions. And to change them, we can change those constraints. So we can keep going, right? We can add a client server constraint. That's going to change some things. It's going to modestly improve evolvability, agility, configurability, things like that. We can add some kind of API, like the very common RPC over HTTP, which is what most people call REST. Or we can bring in GraphQL or anything else. We can keep going, right? We can start slicing at these module boundaries. That's not hard to do because we're just taking whole layers of the system into standalone components. And if we prescribe independent deployability, we get the old classic distributed n-tier architecture. That was one of Microsoft's hot buttons for a while. That was back in the day, I took a bunch of the Microsoft certified professional things, and that was what they said everything should be. But we can keep going. We can keep modifying this because maybe as this scales, we're hitting write saturation on our database. Well, that's okay. We can adopt the CQRS constraint, right? And we start getting different capabilities. Now, this is probably not an architecture that you're not going to be ashamed of. And when I was writing this the first time, it was late at night. I was under pressure. I had some random Pandora station playing, and just forgive me, but this is the song that was playing when I was writing this, and I thought that's a good line, and I haven't gotten around to taking it out of here yet. But yo, you know where it ends. Yo, it usually begins depends on where you start. From the Everlast song, what it's like. So if we start a different place, if we start somewhere else, we can get to a different set of constraints that will get us to a different outcome. Now, instead of taking slices horizontally, like we did get to the end here, what if we sliced it vertically? Well, we need to find those new boundaries. We need to find vertical boundaries, and that's where your well-defined domains and domain-aligned teams start to matter. Because when you do that work, you can actually find those boundaries. So if we go from technical partitioning to domain partitioning, you're now moving in the direction of a modular monolith. And that starts to solve certain problems. For example, if you ever worked on a layered system, it's well organized. It's some guy named Bob says it's clean. And okay, sure, I'll go with that. But the thing is, what tends to happen in a lot of these systems is you make a change. The change starts with your database schema change. Well, if you change your database schema, you better update the persistence layer. And that means you need to update the business logic layer. And that means you need to update the services layer. And that means you need to update the UI. So you've touched the entire thing. What is your testing scope? The entire application. No wonder people say this is not very agile. We got to do a full regression test on our giant application every time we change anything. No wonder we let them all stack up and just do it once. And then we wonder why it's painful. But if we have something like this domain partitioned monolith, and I make a change here, what's the testing scope? Well, everything in this module is scoped internal. So I know for a fact, not only do I know with a strong conviction, but I actually know for a fact that none of these other modules are reaching into there, because not only do I have everything scoped as internal, I have architecture unit tests in place that will break the build if you try to cheat, if you try to just to kind of get everything ready for that Friday deployment that we're not going to talk about. if you just, quietly make it public and start using it, that's going to break the build. And maybe another team somewhere else, they make a change over there. That's got a safe testing scope. That's got a safe testing scope. But we still have database coupling. So we add another constraint into here. Instead of the shared database, we prescribe that we actually partition that database. So one domain module owns one schema inside of that shared database. Because otherwise, my team could go make a change to a table, add a column, change a column, rename column, normalize that table that we kind of, put that on the technical debt bill, put it on my tab, we'll deal with it later. Of course, we know later means never. It was a temporary workaround. Of course, we know that temporary means permanent. But then somebody else who's joining to that table, all of a sudden their stuff breaks and, we're out of there. But if we isolate those, we keep the shared database because we don't need it yet, but we put the same boundaries in our database that every module has its own connection string and its own little corner of the database. Suddenly we have a modular monolith. And so, yeah, we're basically in here. People call it different things, vertical slice architecture, things like that. We have to think about granularity a little more, but it's not hard to move things around in here. It's not a big deal because it's in the same code base. It's kind of in the same everything. We can actually learn a lot about our module granularity while we're still in a monolith. So the thing is, again, we rarely want a direct instance of this style. I call these abstract styles. They're like where you start. It's like an abstract class. You don't want to directly instantiate it. You want to derive it and extend it. We can do the same kind of things. We can create kind of a client server type of architecture. We can bring in that API. We can bring in that independent deployability. We can start to take groups of these modules, just take them out because they're each their own separate package or assembly, if you're a heathen, but I'm among package friends, I believe. Are you .NET, man? Oh, I was making a bad because you mentioned Java JVM, even though we're all welcome. I spent most of my career in the .NET world. It's not your grandfather's .NET, okay? It's better now. It's okay. It runs cross-platform. I do dev in my Linux environment. It's all good, but it wasn't always that way. And yes, I am deeply aware that Microsoft did what Microsoft does. And when they created C#, they basically started with Java, and then they filed the serial number off, and then they sold it as C#. That's what Microsoft, that's the Bill Gates, Steve Ballmer, era of Microsoft. That's what they did. But at least they love their developers. And so we're here. We're almost to another one of these patterns. And in fact, if we maybe simplify things, we say, we're just going to share the database the way we always have. That actually gets you to the service-based abstract style. These are coarse-grained mini-services. This is a very pragmatic architectural style, right? Generally, because these are very coarse-grained, you don't have any distributed transactions. You don't need to worry necessarily about distributed tracing because you're not doing very much in between services. They cover large-grained domain behaviors. But we can put that partition shared database in there. And then what we're doing is we're trading agility for simplicity because breaking up the data is hard, but sometimes it's worth it. But we also get architectural flexibility because I can keep going now. If we're starting to isolate these in the coarse-grained services, we start to isolate the database, then as we grow, we can just change that connection string, one of them, and we're done. We can keep going. We can start making these modules more fine-grained. We can start breaking out more databases. And as we kind of continue down this path, we bring in some high operational automation that kind of makes this work a little bit better. And we keep, we've got those isolated databases now, and we're getting towards fine-grained components at this point. We add one more constraint, that API again, we're back to our microservices. So going from the layered architecture to that distributed end tier is relatively straightforward. Basically, it's easy when you're decomposing along existing module boundaries. It's like tearing that check that's on that piece of paper that you get when you cancel your insurance policy and they return like the $3.18 that I never figured out how that math works, by the way. Like, it feels like it should be higher, but whatever. I've got this little check for $3.18. And you just tear that check off because it's already perforated. There's already a boundary that can go along, and I still managed to screw it up somehow. But in theory, for like competent people, and I'm pointing to you, and particularly the 6 people on Zoom, is it still 6 or am I losing them? Oh, thanks for sticking around. I appreciate you. You're going along those boundaries. But when you're going from your layered monolith to microservices, that's enormously difficult because the hard thing that you're changing is your module partitioning. And so what I've landed on is a new taxonomy that really kind of starts with the hardest constraints to change. That's what going from here to here, that's what takes years. Going from here to here takes a sprint. Going from here to here takes a sprint. And so one of the neat things about this is a simplified version of the diagram. One of the neat things is you can get an idea of how hard that migration is going to be just by looking at how far apart they are. It's yeah, just by looking at how far apart they are. So decomposing the monolith is not necessarily difficult, but decomposing against module boundaries is. Now, the 5th one is granularity need not be absolute. Mark Richards said, a single-purpose, independently deployable unit of code that does one thing very well. That almost sounds like he's prescribing lambdas or functions or something like that. Very, very, very fine-grained. But not necessarily. You know, one of the things I like to do is start coarse and get finer as necessary. So I'd rather go from coarse to fine than fine to coarse in a distributed system. So I can look at, you know, aggregate stack traces. I can look at inter-service communication. I can look at traces and everything else. And because the reality is being an architect is almost as much about monitoring and measuring as it is about design. Like I was a DBA for a period of time in my career. Please don't hold that against me. DBAs are rarely invited to parties, I found out. That's because people like to talk about the DBAs at the parties, and it's just less awkward for everybody if the DBA is not there. You know what DBA stands for, right? It stands for don't bother asking. Yeah. But when I was a DBA, it's like, okay, I'm going to help design the schema. I'm gonna help you with maybe your stored procedures or whatever if it's, you know, the 90s. I think stored procedures are great. I think we threw out the baby with the bathwater in a couple of cases, not universally, but we've got great AI. We still can't get a good ORM. I kind of miss Gorm. Anybody else? It was the groovy ORM. It used a lot of magic. I like magic. It was kind of cool because you could have like your repository and you could just make up a method and it would actually implement it for you at runtime. So I could have like get invoice by supplier number, and the groovy like metaprogramming stuff in Gorm would just do that for me. You know, now we have Hibernate and Link and everything else. Or Gorm was kind of cool. But we want to be thinking about that. But I was a DBA. The thing is, I'd like build all this stuff, and then it's not like I could just sit around drinking coffee all day. I was always busy, and mostly what I was doing was monitoring the system. And as an architect, most of what I'm doing is, well, not most, but a lot of what I'm doing, some amount of what I'm doing, a chunk of what I'm doing, is measuring architecture. You know, I'm looking at metrics. I wrote a whole chapter on metrics, and all my volunteer reviewers said you could probably lose that chapter. I'm like, I could, but I'm not going to, because it's actually valuable. It's actually worth understanding how different business stakeholders are going to measure the success of your system. And there was a few things like that. Like, I'm not a manager. I'm like, no, but you need to be able to talk to the managers. You need to be able to speak their language. You need to understand what they really care about, because they're going to say stupid stuff. And you got to figure out what they really want. And these are things you can measure. So when you're building these systems and defining these constraints, what is the business value of every one of these constraints? because we don't make this thing small for the sake of being small. We want to do it because it's going to translate to a win. So granularity need not be absolute. And I'm a fan of multi-grain services. Some of them more coarse-grained, some of them more fine-grained. When you're looking at load, that's a big one. When you're seeing like one of these coarse-grained services, like 90% of the load is like 10% of that coarse-grained service, that's a great candidate to extract. And if your coarse-grained services are not layered but modular, then you can just pick up those modules, put them into their own runtime, their own container. And the last one, because I don't even know what time this is. My watch says 6. I think it's actually 7. I didn't feel like changing my watch because I'll be home this time tomorrow. The last one that I'm going to talk a little bit about is the monolith first is often practical. I'm a huge fan of the modular monolith because that gives me all the architectural flexibility I might ever want in the future without all the complexity that comes with microservices. And that way I'm only taking on that complexity when it's going to translate into a win. Now, that's a hard thing to do. People worry about structural decay, right? Because, oh no, what if somebody quietly turns that internal to public so they can peek into your module? That's why I use things like architectural unit tests or architectural fitness functions is something that Neil Ford likes to talk a lot about. But there are a lot of ways to manage this. And so, yeah, monolith first is often practical. Do I have a little thing on the bottom there? Oh, yeah, provided adequate architectural enforcement and governance is in place. That's the key thing because, all systems tend to entropy or something like that. Somebody said that at one point. Does that sound right? Entropy, chaos. But yeah. All right, let's wrap this up. Let's go have a second. Let's cut the cake. So the quick recap: nobody wants microservices. Our job as architects is to figure out what they want and deliver the right set of trade-offs. Over-engineering is a poor substitute for proper requirements analysis and architectural design. There's no single definition. Don't let the flat taxonomy fool you into overlooking key aspects and then let it put you into a corner. Nobody puts baby in the corner. Okay, you got that one? All right. My reference earlier, by the way, was a reference to the movie Real Genius. Okay, you're nodding. Classic Val Kilmer film from back in the 85, I think. Because you said so, he had the microphone. He says, "This is God," and I followed with, "You've been a very naughty boy." You see what happened was there was this. Never mind. Just watch the movie Real Genius. Does it hold up? Do you think? Okay. The movie that holds up the most from that era, in my opinion, is Sneakers. Fantastic movie, underrated movie. Robert Redford, Sidney Poitier, River Phoenix, the other guy, Dan Aykroyd. Great movie. Anyway, use a more sophisticated model to design an architecture that fits but can evolve over time. And also, remember, you can't just prescribe microservices. You have to be more precise. This is why I like architectural styles over vague, nebulous patterns. The trade-offs are often more than we expect. One person's 1 star, somebody else's 5 star. One of the things that my wife noticed in her hobby is that often when people give 1 star reviews, the things that they hate are precisely the things that she loves. Nothing needs to be one size fits all. We went somewhere. We were in Bali, of all places. And on the second night at that hotel, or wherever it was, I don't even know if it was you can call it a hotel. We went back to the bar, and the bartender says, "Oh, Mr. Carducci, welcome back. Do you want the whatever the cocktail I was drinking?" He says, "Do you want the same again, or do you want to look at the menu and try something different?" And some people hated the fact that a bartender would dare presume what you might want to order, and that they speak with you with the impudence of familiarity when they are in the service industry and I am the customer. Like, people actually think like that. And we loved it. It was amazing. That's why we ended up canceling the rest of our trip around Bali and just stayed there that week, because it was such a nice place to be. So adopt a holistic architectural approach that surfaces both the technical and non-technical implications of every architecture decision. You also will need the tools to drive meaningful organization-wide changes. Decomposing monoliths is not necessarily difficult. Don't be fooled and think you can't grow in the microservices. Understand the constraints or atomic architectural primitives that underlie all these different patterns. When you have that, evolution becomes much better. Granularity need not be absolute. Take a more holistic approach that balances cost, complexity, scale, things like that, and use a more sophisticated architectural approach to design an architecture that fits now and can evolve as your needs do. So that's that. That's all from me. I think that's my LinkedIn. I'm not 100% sure. You should scan this and see where it goes. There is only a 5% chance that it's a Rickroll. 5%? No, that's 1 in 20. I mean, if you're feeling that lucky, let's go find a casino. We'll go play roulette or something. I'm in. I'm pretty sure that's my LinkedIn. And I'd love to stay connected and stuff like that. I have exciting things that I'm going to announce at some point in the future. But for now, I want to thank all of you. I want to thank the 6 of you and whoever's watching this on replay. I don't know. Is this gonna go on the YouTubes? All right. And well then that's gonna be fantastic because I think the most important thing that I told you was that secret. That one weird trick. And now you have it, and now you have it. So be blessed. Thank you so much. And now I think it's time for the giveaways. Woo! Let's do the giveaways and then cake. Yeah, let's do it. Let's do the books.
While we set, I guess we don't need more, or do we? Do we still need the mic?
Bag, the doomers. Yeah, make sure you fill out a slip. 2 copies. Signed on demand.